Now coming to the next layer, that is a command layer. So before that we have seen how to implement the signal layer. Now transaction level test cases written using Verilog or VHDL are typically implemented on the top of the command layer. Okay. So suppose you are creating an environment with the help of Verilog. In that case you will write BFM, right? So in one side of the BFM will talk to DUT. Okay, so that is signal layer. Okay, so and the other part of the BFM will talk to test case, so that is called as transaction layer. Okay, so that is what they are trying to say. Only two interface, one is procedural interface, one is physical interface. So that BFM of a Verilog should sit in command layer. Now the command layer typically contain bus function model, physical level drivers, monitors and checkers associated with various interfaces, and physical level protocol present in the DUT. So before that we have seen example of USB. Okay, so in USB we have seen what all the bus function models that will sit in command layer. One is ARM by HB master. Okay, so that we used one master BFM, and we have used ARM by HB interface checker. Okay, so one checker that will also sit in command layer. Then USB checker and USB transaction module. So these hardware bus function model. So these are the four modules that will sit in the command layer. Now the command layer provide a consistent low level transaction interface to the DUT regardless of how DUT is modeled. So if you see that our BFM is having low level interface, means that is physical interface that will talk to DUT, but that is independent of the implementation of the DUT. We only talking through pin. We don't know how they have implemented the DUT. So at this level, a transaction is defined as an atomic data transfer or a command operation on one interface, such as register write, the transmission of an Ethernet frame, or fetching of an instruction. So if you're performing verification at this level, what you can maximum do? Towards processor side, you can write the data inside the register and you can read the data inside the register. Okay, coming to the hardware bus function model, you can transmit some data. So DUT will take that data and receive some data, and after that it will based on that information, control information, it will transmit the data. So here, so at this level you will tell the that thing as atomic data transfer. Okay, so this is atomic layer. So atomic operations are typically defined using individual timing diagram of the interface specification. So if you will say if you will see the specification in which we will find the timing diagrams. Okay, so like those type of diagrams you can implement in test cases. Okay, so that is what they are talked as atomic operations. So those waveforms, whatever is there in the specification, if we achieved that thing in the in our with our DUT. Okay, so that is atomic operation. Reading and writing register is an example of atomic operation. So this is, they are talking towards the processor side. Okay, reading a like control register or status register, and writing, it is a atomic operation. The command layer provide method to access the register in the DUT.